Morning, Onnandal, beloved secretary, the principal and the vice principal of King's Engineering College, and then the beloved
Thank
HOD of the
you for
department.
your introduction. And now it's the time for the presidential address by our chief guest, Dr. Somasundram sir. Please,
Thank
sir.
you. So, beloved head of the department, Mr. Professor Pushparaj, and then organizing secretary, Professor Shantaram and Professor Melvin, and all the faculty of King's Department of Mechanical Engineering, King's Engineering College, and also my own colleagues, Professor Senthil and Professor Sundil Kumar and Professor Ganesan from my NITTR Chennai. I welcome you all to this national conference on energy and manufacturing scenario. So this national conference on manufacturing and energy has come at a time when the traditional manufacturing systems have been confronted with severe challenges and competition as they have passed through the second and third industrial revolution. So now this advanced manufacturing is an alternative to overcome the challenges and also to meet the challenges of industry 4.0. So this industry 4.0 makes use of the manufacturing systems with the help of IoT, big data, cloud computing, and artificial intelligence. So as a result of this, what happens? All the processes in the smart factory are integrated with these key enabling technologies. And moreover, it also integrates the independent subsystems to transform the existing production lines into a flexible and a reconfigurable ones so that this CPS, what we call, is another critical solution. There is what we call cyber physical systems, which is, even though it is a complex engineering system, which integrates this physical, computation, networking, and communication process. So even though the industrial countries have enjoyed the blessing and prosperity of this first and second, third industrial revolutions, so now this advanced manufacturing has been benefited with the use of this industry 4.0. And coming to the first theme, namely the rapid prototyping, which is one of the important theme in this national conference, one of an area where rapid prototyping has now been developed as a key prominent area is functionally graded rapid prototyping. That is what we call FGRP. So FGRP is a novel design and a technological framework which enables the controlled spatial variation of the material properties through the continuous gradients in the functional component. So I think many of you would be aware of this functionally graded materials. So this functionally graded materials are the materials with the spatially varying composition or microstructure, which are almost omnipresent in the nature. So such variations are traditionally achieved as discrete delineations in the physical behavior by fabricating the multiple parts comprised of different materials. And then finally, we assemble them by using this CTD, what we call computational topology design. And then we have SFF, that is solid freeform fabrication. So by using these technologies, we create a building component with controlled micro and macro architectural features. So this rapid prototyping, the researchers can do a lot of work in this FGRP, what we call functionally graded rapid prototyping. And then coming to the another theme of this conference, namely the non-traditional machining, where this wire cut EDM is one of an indispensable machining technique for producing the complicated cutouts through difficult to machine metals without high cost grinding or expensive form tools. And as far as the wire EDM is concerned, we have the research going on in the wire materials which has been used. So now the brass wire electrode is one of the extensively used tool material. But along with the recent diversification in the application of the manufacturing fields, the demand is expanding for the wire electrode with the performance superior to the conventional brass wire electrode. So these electrodes are generally zinc coated wire with a copper, brass, or a steel core, and the brass containing either a small amount of chromium or a higher concentration of zinc. So that is where the research can be done in wire cut EDM. We can explore the cryogenically treated wire materials along with the zinc coated brass wire. And then coming to the next one of the important theme on casting and welding, where we have a solid state welding process in which the friction welding is one of another important key research area which produces high quality welds in a very short cycle time. So this friction welding is capable of welding carbon steels, alloy steels, and then we have aluminum alloys, copper alloys, and then it can be used to join many combinations of dissimilar metal. And along with friction stir welding, it is used in aerospace to join the lightweight aluminum to high strength steels. And then we have explosive welding, also what we call explosive bonding, where the parts to be welded or metallurgically bonded as a result of the oblique impact pressure by a controlled detonation of an explosive charge. So this advantage of this explosive welding is that it has a high quality bonding, high strength, and then we have no distortions and porosity, and it also does not affect the microstructure. And another one important area where the researchers can contribute is a radiant energy welding, where in the radiant energy welding, we have the electron beam welding or a plasma arc welding, where we have a stream of electron or a beam of electromagnetic radiation, which is used to provide heat at the point of welding. So unlike this arc or gas welding, this process can be carried out in vacuum or at low pressure, so we can get high quality welds. Then another one area is thermit welding. So this thermit welding is an exothermic welding process in which the workpieces are joined by heat obtained by the chemical reaction of a thermit mixture consisting of iron oxide and aluminum powder. And then we can also contribute in pressure gas welding, which is a slight variant of oxy-fuel gas welding, where the parts to be joined or heated by the oxyacetylene flame, and then we apply an axial pressure of about 3 to 7 Newton per meter square in order to join the components. So these are the areas in which the researchers can contribute as far as the welding is concerned. And then coming to the casting, casting is concerned, one of the prominent area is LFC. I think many of
Sorry
them.
for disturbance, sir. Can you hear me?
Yes, sir. Yes, sir.
Actually, your camera panning is not up to our level, sir. Could you please pan our camera?
Oh, 1 minute.
Yeah, face is not visible, it seems. Yeah. Could you slightly pan, sir? Yeah, it is okay, sir.
Okay.
A little bit lower, sir. Little bit lower.
Oh. Is it okay?
Yeah, okay, sir. Fine, sir. We can proceed.
Okay, sir.
Sorry for the interruption, sir.
Okay, thank you. So, and then coming to the another one research area where the people can contribute in casting is that lost foam casting process. So this lost foam casting process is one of a pioneer in this casting technique, and then it is an alternative to the conventional foundry methods. So this lost foam casting process permits the production of complex components, and then it opens up the new scope for casting. And then we have a greater design for the designers than when casting in the permanent mold. And then we can have undercuts, angled channel, and then we can have contour optimized cavities are possible. And one of the uniqueness of this lost foam casting is that there is a reduced number of machining processes after the casting is completed. And then we have another one important area called moldless casting. So in this moldless casting, the molten metal is dropped on a substrate, and we can make layers of the one another, and it has a potentiality to be used for complicated casting which are difficult to make, and the molds and patterns in the conventional way. So this is the other term, the other way where we can call this moldless casting is called droplet based manufacturing process, where the castings are constructed by the molten metal droplets having a proper flow rate, temperature, and diameter. So this moldless casting is another one of the upcoming area in this casting is concerned. And then coming to another one important theme in this conference, namely the composite materials, where there is a continuous trend which is going on in the material development. And also this composite materials, they are it has even though it is lightweight, is very stiff, and it has a very good high strength to weight and stiffness to weight ratio. And the designers have found this composites to have the unmatched design potentials. So what happens, the one of the important recent developments in composites include biocomposites. So biocomposites, and then we have green composites, and then we have self-healing polymer composites, and then we have thermoplastic composites, and then we have carbon nanotube composites. So this all these composites have improved material properties, and then they have good stiffness, high strength, and then they have very good low weight and corrosion resistance, which make the composites to be applied in spacecraft, pressure vessels, abrasive materials, and then in cutting tools. And then one of the important theme of this conference is the nanotechnology, which in turn has complemented this energy also. So another one important theme of this conference is the energy. So this nanotechnology has in turn complemented this energy also, because at the root of opportunities provided by nanotechnology to improve our energy security is that almost all the steps of energy conversion, like charge transfer, molecular rearrangement, chemical reaction, they take place at the nanoscale. So thus the development of new nanoscale materials, as well as the methods to characterize, manipulate, and assemble them, it creates a new paradigm for the revolutionary energy technologies. So as far as this nanotechnology for energy is concerned, there are three areas in which the nanotechnology can contribute to the energy sector. So in energy conversion, and then in energy storage, and then in energy savings. So as far as the energy conversion is concerned, nanotechnology plays a key role in solar thermal energy conversion, solar photovoltaics, and then hydrogen conversion, and then we have bioenergetics, and then we have thermoelectricity, thermophotovoltaics, and then in fossil energy. And then coming to the energy storage is concerned, the nanotechnology plays a key role in rechargeable batteries, hydrogen storage, and then in supercapacitors. And then finally, in energy savings is concerned, nanotechnology can be used in insulation, and then more lighting, efficient lighting point and lighting areas for large areas. And then it also plays a very indispensable role in combustion. So these are the areas, three main areas in which the nanotechnology can contribute to the energy sector. That is in energy conversion, energy storage, and then in energy savings. And as far as the energy conversion is concerned, we know that the photovoltaic is the only technology which helps us to transform the sunlight into electricity. So you all of you would be aware of this fact that at the heart of this photovoltaic cell, we have the silicon as the material. But what is the issue with this silicon? You know that the silicon does not exist in the nature as silicon. So we have to extract silicon from silica. So even though silica is abundantly available in nature, what we have to do, we have to extract this silicon from silica. So processing this silica, what happens? It is an energy intensive process. Why? Because it takes about 1 or 2 years for a conventional solar cell to generate as much energy as being used to extract this silicon from silica. So now the main aim of these researchers who are contributing in this nano solar photovoltaic is that we have to replace this silicon. So how to replace this silicon? So the silicon can be replaced by a dye sensitized solar cell. So in this dye sensitized solar cell, what happens? The silicon is now replaced by a polymer dye. And now, where the nanotechnology has contributed in this dye sensitized solar cell is that the nano crystals of cadmium selenide or cadmium sulfide and lead sulfide, what happens? It provides a unique advantage of a tunable band gap. So what is this tunable band gap? Is that the wavelength at which the solar radiation absorbs or emitted can be adjusted just by varying the size of the nanocrystal. So this is one of the advantage of this nano solar photovoltaics, where in dye sensitized solar cell, the polymer dye is now replaced by the nanocrystals of cadmium selenide, cadmium sulfide, and lead sulfide. So these are some of the research areas as far as the manufacturing and energy is concerned, where the researchers can contribute more. So now I also wish all the researchers who are presenting in this conference, and also I also wish all the organizing secretary and organizing chair for conducting such an important area in the mechanical engineering, that is energy and manufacturing. So I wish a grand success for this national conference. Okay, so I thank all the organizing secretary and organizing chair for inviting me to deliver this inaugural address. Thank you, sir.
Thank you so much, sir. Thank you so much for your presidential address. Now it's
Thank
the
you.
time to invite our beloved Vice Principal, sir, Dr. Sivakumar, sir, to conduct the felicitation address.
Thank you, Ashwin. Thank you. It's indeed a great pleasure to listen to the lecture given by Professor Somasundram sir. He has thrown
Good,
light
sir.
on many of the. Yeah, can you hear me, Ashwin?
Sir, camera is not panning, sir. Could you please pan your camera?
1 minute, 1 minute.
Little bit upward, sir.
Is it okay?
Somehow okay, sir.
Okay.
Fine, sir. Thanks.
So, the chief guest of today's function has thrown light on many of the important topics, like in the energy sector and in the manufacturing sector. I hope the participants will be much benefited out of this particular program. Thank you very much, sir, on behalf of King's College of Engineering. And at this outset, the secretary, principal, and on my personal behalf, I'd like to thank the resource person, and I also wish all the participants to have a wonderful interactive session on this conference. Conference of this nature definitely is meant for exchanging ideas. Everyone cannot be a master of all the subjects, but we can focus on very few subjects which are most interested to us, and these subjects can be pursued higher when you go for your PG, project works, or maybe your PhD studies, and you have to be a master on that particular subject and make a name out of it, at least in the national level. That's how it's supposed to be. Now, I request all the participants to be attentive for be present here, not only for your own session, but for the entire session. Then only you can learn out of something out of it. And this program is an opportunity for validating your own idea with equally scholar people. I hope the participants will be utilizing it. And the organizers of this program, headed by the HOD, Dr. T. Pushpat sir, and the organizing secretaries, Dr. P. Sandaraman and Melvin Jagadish, with the fellow mechanical professors. I hope you will be making the session very successful one. I wish you all the best of this particular program. Thank you for that.
Thank you so much, sir. Thanks for the felicitation address. Now it's the time for starting our technical paper session. So I need to thank everyone who attended this function, who attended this live streaming, the grand success. Now the participants are requested to access our Google Meet link provided in your individual WhatsApp numbers. So please access the Google Meet code and we will be conducting the meeting in the respective Google Meet links. So thank you everyone for attending this seminar.